This is R.D. Sharma solution, class 12, chapter 6. Determinants exercise is 6.2. So we have already done this type of questions, and I told you that we'll do this one. So 10th and 11th we are going to do. So we'll do the 10th one. So we need to just, because this is square, write the actual numbers. So 1, 4, 3 square is 9, 4 is 16, 2 square is 4, 3 square is 9, 4, 4, 16, 5, 5, 25, 3, 3 is a 9, 4, 4, 16, 5, 5 is 25, 6, 6, 36, and 4, 4 is a 16 again, 5, 5 is a 25, then 6 square, and then 7, 7 is a 49, right? Okay. Now we'll do certain thing so that we can get two rows same or two columns same. So these are different rows, row 1 to row 4. So we'll do two things here. Row 3 will change to row 3 minus row 2, and row 4 will change to row 4 minus row 3. We can do it together also. We can do it by one. So let's say we are doing R3 minus R2. So 1, 4, 9, 16, 4, 9, 16, 25 will remain like that. And 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 5 plus 4, 9. And 36 minus 25 is 11. Now, this, you can easily write this 16, but I can tell you that in exam you have to do one by one step. But I'm doing it directly to R4 minus R3. So now 16 minus 9, 25 minus 16, and 36 minus 25 is 11, and 49 minus 36 is 3, 1, 13. Okay. Now you can add or subtract any value to any row or column. This is also a property. So if you see that the third row and fourth row, they differ by 2. What does it mean? The difference between these two last two rows is only 2. So if you add 2 to the third row, what do you get? You get the fourth row. So we are going to add 2 to row 3. So when we add 2, the number 2 to R3, what do you get? You get the row exactly similar to the last row. So 1, 4, 9, 16, 4, 9, 16, 25. And this is 5 plus 2. I am adding now 2. 5 plus 2. So 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 2 is 13. Then you have 7, 9, 11, 13. Okay. So what do you get? These third row and the fourth row are exactly similar. The determinant is 0. Now I am clearing it because we are going to do the next one. So we have A, B, C, A plus 2x, B plus 2y, C plus 2z, and x, y, z. Now let me tell you, there are multiple ways to solve or go ahead with the same kind of determinant. I am giving you one method. You can have your own method. So A plus 2x, B plus 2y, C plus 2z, and x, y, z. This is our matrix. Now see the pattern. It is A plus 2x. Second row. The first row, if we add twice of the third row, you'll get A plus 2x. That is, if you multiply 2 in third row and add it to the first row, you'll get A plus 2x. Similarly, you add this 2 twice y plus b is same as the middle row. Okay, let me tell you what I'm trying to suggest. R1, R2, 3. Row 3 we are multiplying by 2. That is, 2 of x, twice of x has to be multiplied with a. So we are changing R3 to R1 plus twice of row 3. Twice of row 3. Okay. Now we will get the middle row. So A plus 2x, B plus 2y, and C plus 2z. A plus 2x, B plus 2y, C plus 2z. Here you get x, y, z. And the two rows, the first one and this one, they are exactly similar, right? When two rows are similar or two columns are similar, the determinant is 0. One more step you can do, R1 is R1 minus R2, or R2 is R2 minus R1. You can do that. You will get a 0 because they both rows and columns are both rows are same. Now the next question, we can open it the way we want, but the best way is without opening if we can apply the properties. So we'll do it using a different approach. How do we do this? What kind of value we put so that two rows become equal or two columns become equal, or two column or row, two row or two column, that means the determinant is 0. So what do? We do here as this. See, we have A, B. If we write A in place of B, in the first row we get A plus C. I'm writing B, A in place of B, then A square. Then we have in place of B, we're writing A. In place of C, I'm keep it like C. In place of B, just write A. So you see, this is the first row and the second row, they are exactly similar. Whatever else happen, but the first and second row are equal when we wrote A equals B, determinant is 0. That means A minus B is a factor of this particular determinant. If we take any expression like this, ax square plus bx plus c, for what value of x the expression is going to be 0, that value is called the root. That is, say x equals 1, for example, so x minus 1 is the factor. Similarly, the same logic goes for when we put b equals c. When we put b equals c, what will happen? The second and third row will become equal. So I'm writing, see here, I'm writing b in place of c and c in place of b wherever I want, so that I can make these two rows, that is the third row and the second row, equal. So when we put b equals c, b minus c is a factor. B minus c is a factor because two rows are equal. That means the determinant is 0. Now coming to the third one. If you put a as c, that is c equals a, then you see the first row and the third row will become same, will become identical, will become similar, right? So when you take c equals a, the third and first row becomes identical, which I am showing also. So that means the logic which we use for a equals b, a minus b is the factor, this goes same for this one also. That is c minus a is also a factor. When you put c equals a, it's going to be 0, determinant is 0, so c minus a is a factor. So what do you get? A minus b minus c, these are the factors. Now when we multiply the diagonal, we have to multiply diagonal, a, c plus a, and c square, b square, c square, it, because all a equals b, b equals c, c equals a, so we can just change. Now let us say b is equals a or c equals a, right? We just need to see the power. Don't worry about the values. So a multiplied by this, a plus a becomes 2a. This is a square, for example. This gives you a to the power 4. So there will be 4 factors. 4 factors here. 3 factors we already got, a minus b minus c, c minus a. Since the multiplication of diagonal is saying that it is a raised 4, so there is this, the degree or the order is 4. That means, what do? We say they are 4 factors. Now let me just show you how the other factor will come. I am just adding the second row with the first row with the second row. So we have a, I'm just writing it, and I'll just show you how do we get the final factor. Now just add this a, b plus c, first column and second column we are adding. Or you can also do that second column, you can change second column plus first column. So a plus b plus c, a plus c, you get a square, b square, c square. Then you get a, b, c. Now you can take a plus b plus c common. When you can take a plus b plus c common, that means a plus b plus c will also be a factor. So a minus b minus c, c minus a is a factor. A plus B plus C, what we see here after adding the column 2 and column 1, you also get that ABC, A plus B plus C is this one. So we can take common. So we have three factors now: A minus B, B minus C, C minus A, and A plus B plus C. So there are four factors. A raised 4, we need four factors. I hope you got the idea. A minus B, B minus C, C minus A, and A plus B plus C. So we have four factors. This is the factor. So we can equate this determinant with these factors, but not we cannot make it equal until we have also considered the some constant. So we can write it as A minus B, B minus C, C minus A plus B plus C, but we need to consider lambda or some k. That is, there will be some value. It can be 1, it can be 0, whichever is there, but it has to be some value. Now what we'll do is we'll put some random values. For example, A equals 0, B equals 1, C equals 2. Please remember, these are, I said random, but normally we write A0, B1, C2, and normally this gives you the answer. So left hand side also will put A, B, C as 0, 1, 2. So I am putting A as 0, B as 1, C as 2. Here also we have to replace A and B and C by 0, 1, 2. What do you get? 0, 1, 4. A square is 0. No, A square you have 0, 1, 4. Then you get 3. I'm adding B plus C. I'm adding C plus A gives you 2. And A plus B you get 1. So this is equal to lambda into A minus B. What is A minus B? Let me write A and B here. 0, this is 1. This is 1, this is 2, this is 2, and this is 0. So 0 minus 1 is what? Minus 1. 1 minus 2 is what? Minus 1. And 2 minus 0 is 2. So minus minus is plus, 2 into 1 is 2. So ultimately what you got? This whole is 6. 3 to the 6, because 3 is also there. So this lambda 6. Now how to find out the determinant? It's the way we have been doing. 0, I'm opening it using the first row. 0 something minus 3 something plus 0 something. So if you take 3, the minus will be 1, 2, 1, 4. This will be 4 minus 2 into minus 3. 4 minus 2 is 2, minus 3 into 2 is minus 6. So minus 6 is equal to 6 into lambda, and lambda will be minus 1. So the first step which you started with lambda, here you just replace lambda with negative 1. You just replace lambda with negative 1. If you don't want negative, you can change any of the sign, like A minus B can be done as B minus A, or B minus C can be done as C minus B, or C minus A can be done as A minus B. But you can also have negative, it doesn't matter. So this is how we solve. This is a different method of solving determinant. This is also we are going to solve using the same way. So I'll just go through it because we have discussed the question number 3 in great detail. So here, if we take A equals B, B equals C, C equals A, then the rows will be similar. That is, when you put A equals B, the first two rows become identical. If I am writing A as B, I am writing first row as A. In place of B, I am writing A. In place of B, I am writing A. So what do you get? First row and second row becomes exactly similar. So when we place A as B, A minus B is a factor. Similarly, when we put B equals C, then again two rows become same. Okay, the second and third. What about the third one? C equals A. Again, first and third row become similar. Now multiplying the diagonal, 1 into B into, let us say it's A, you can write B in place of A in place of B, whichever. Ultimately, when you multiply, you get raised to the power 3. Even if you do B cube or A cube. So the degree is 3. The degree of the product of diagonal elements is 3. That means, what do? You can just have A minus B, B minus C, C minus A. You don't have to go for any other thing. So it will be lambda A minus B, B minus C, C minus A. And since the degree is 3, so you don't have to worry about any other factor. And if you remember that the a, b, c value which we generally choose is a equals 0, b equals 1 and c equals 2. This is general way we choose the value. So let us take a equals 0, b equals 1 and c equals 2 and c equals 2, right? So when we write this, there can be different values also, right? This is a common value which gives you normally the answer, but there are certain other values which also you can put. Sometimes you put c equals -1, sometimes b is 2, like that. Okay, so I'm putting left hand side, right hand side these values. So this becomes determinant. So this is I'm just writing or replacing the value of a, b, c in here. Now just open this. I am opening it using the third column because there are two zeros. So it will be 2, it will be in plus 2, and what do you get inside? 1 1 1 2. So this is minus, this is plus, but don't worry about minus plus here because it will be 0, but you have to write actually, right? So now I'm opening with 2, so you get 1 1 1 2, 2 minus 1, and you get 1 into 2, that is going to be 2. So 2 left hand side. Now put a as 0, b as 1, c as 2 on the right hand side as well. 0 minus 1, 1 minus 2, and 2 minus 0. What do you get? Minus 1 into minus 1 into 2. Minus minus become plus. You multiply it by 2. So what do you get? It's 2. So 2 equals to lambda. So lambda will be equal to 1. So just write 1 in place of lambda, and that is going to be your final solution. Next one is we'll apply the property, and then we'll see where we can solve it, because you know all of these cannot be solved using property. Determinant will not be 0. We need to open it somewhere. So we need to make the determinant so easy so that when we open, the calculation is somewhat lighter. So what I'm doing is column 1 equals column 1 minus column 2, and column 2 equals column 2 minus column 3. So x plus lambda minus x is going to be a lambda. X minus x plus lambda will be minus lambda. X minus x is 0. Now these two. X minus x is 0. X plus lambda minus x is lambda. X minus lambda is minus lambda. So you put minus lambda there. So I have applied C1, C2 both simultaneously here. You get x and x plus lambda. Now let us open it using I'm using the first row. So lambda minus lambda x plus lambda will come. Don't worry about 0. Eventually it's going to be 0. Then the third value of the first row, x. So minus lambda 0 minus lambda. Now let us do the second one first. Second part. What it is going to give? X into minus lambda is plus lambda square, and minus lambda into 0 is 0. So you get lambda square x. Now coming to the first one, lambda. Now lambda x plus lambda, and minus lambda minus of minus, because it will be minus lambda x, but since we are subtracting, it will be plus lambda x. So this will be lambda x plus lambda square plus lambda x. Lambda was already outside. So 2 inside 2 lambda x plus lambda square. Let us multiply the outer lambda with inside 2 lambda square x plus lambda cube you get. But one more thing is remaining, which is x lambda square. So just write x lambda square. These can be added, so it will be 3 lambda square x plus lambda cube. Okay. Now you can take lambda square common. You get 3x plus lambda also. This is also the way you can write. Okay, the next one. Let us see what we can get, because we cannot do anything. We have to open it. There is no way. There is one more thing you can do. I can just guide you through that, but ultimately the best way is to just open using any of the row or column. This is the way you should do. There is no other way. But what I am trying to suggest is I am adding column 1, column 2, column 3, and change and putting it in C1 so that I can get 1. I'll subtract it, I'll just make things easier. That's it. But the computation will never get easier, because if you are making your life easier here, it will be tougher somewhere else. So I'm adding column 1, column 2, column 3. You get a plus b plus c. B c remains, ab remains, ca remains. Now a plus b plus c I'm taking common. So you see also in the answer a plus b plus c is already there. So 1 1 1 b c a b c a. Okay. Now subtract. That is the row 1 and row 2. Row 1 minus row 2 I'm doing. So 1 minus 1 is 0. B row 1 I'm changing as row 1 minus row 2. B minus a it will be c minus b. Again row 2 I'm changing, row 2 minus row 3. So 1 minus 1 0, a minus c it will be b minus a and 1 c a, right? Okay. Now we'll open it using the first column. 0 into something doesn't matter. 0 into something doesn't matter, because it is ultimately going to be 0. We are only concerned with 1 plus 1. What do you get? B minus a minus c, c minus a, b minus a. Because as I said, you have to compute this one. And that is going to come as b minus a, c minus b, a minus c, and b minus a. So when you multiply this, you get b minus a whole square minus a minus c into c minus b. That means when you multiply these, means take the determinant of this 2 by 2, ultimately you are going to get a square plus b square plus c square minus ab minus bc minus ca. Remember, a plus b plus c was already outside, right? So b minus a whole square minus a minus c, c minus b, just open it. Don't worry, it's going to come as a square plus b square plus c square minus ab minus bc minus ca. And when you multiply this with a plus b plus c, it is nothing but a cube plus b cube plus c cube minus 3abc. So in the beginning of this question, I said rather you do like this, or you can do the easiest way, open it using any row or any column. This question will take up in the next discussion. Till then, thank you so much. Take care of yourself.